Agenda. In this short video, I'll discuss the following topics. Topic number 1. I'm going to show you a general format. This general format includes following several different tests. One sample, and we know from the previous chapter. B. 2 samples from 2 populations. C. Matched 2 samples. Actually, we calculate difference. Topic number 2, in-class exercise. Test of equal mean using 2 samples from 2 populations. And also we have 2 methods. Method 1, we are going to use formula. So we calculate 1 by 1. B, method 2, using Excel function. Now, let's look at the general formula. Okay, so I'm going to write the general one. Okay, as before, so we are going to draw some distribution. So it can be normal, or it can be the standard. It can be normal, or it can be student t. Okay, they are symmetrical. Okay, the general one is suppose our hypothesis is. So I'm going to use delta. So this is mean. Delta equals delta 0. Okay, and I'm going to use two-sided test. So this is half alpha, and this is another half alpha. Okay, it's the middle is 1 minus alpha. Okay, so this is can be our delta 0. Okay, this includes the 3 potential. Of course, the alternative hypothesis is delta mean not equal delta 0. To save space, I'm not going to write it. Okay. So scenario number 1, remember our mean equals x0. So this is a special case for 1 sample from 1 population. Okay. And for this chapter, we have another one. Okay. So x1 mean minus x2 mean equals mu1 minus mu2. Okay, and we can always think of this on the left hand side. So this is delta mean. So delta 0 equals x0. Okay, for second case, it's delta mean equals x1 mean minus x2 mean equals mu1 minus mu2. So these two are population. Okay, and the third one is we look at the difference. Okay, so this is matched case. So actually is x1i minus 2. So this is we call the difference. Okay, then is difference equals we can call the difference 0. Okay, so this is like a special case. Okay, it's a general format. Okay, we have 3 different subcategory. Okay, and as we mentioned before, we have 3 decision rule. Okay, decision rule I'm going to write here. Okay, so this is rule number 1. Okay, rule number 1 is inside the region we accept. Okay, so this is we accept. Okay, and decision number 2 is distance. Okay, so actually our z value is less than z critical, and we accept. Okay, I'm going to use all accept. Okay, so if inside the range we accept, if the z value, and for this case we should use half alpha. Okay, so if z value, if absolute z value is less than z critical value, then we accept. Okay, decision rule number 3 is p-value versus alpha, as I mentioned, and so they say if the p is higher than alpha, we also accept. Okay, and to be exactly, we fail to reject, and I prefer is accept. Okay, now is the hypothesis. So rule number 1, I'm going to put this here. It's simply we have delta 0 plus minus margin of error. Okay, margin of error. Okay, so actually the key is for the different, so this is case number 1, case number 2, case number 3, and basic idea are the same. The only thing is how to calculate margin of error. Okay, so this is true, how to calculate z value. Okay, so z, suppose we calculate z value. So this is delta mean minus delta 0. Okay, so this is to calculate standard error. Okay, standard error. Okay, for different case, we use different formula to calculate standard error. Okay, and it is also true for the t-value. Okay, the t-value is half r divided by alpha, and we have quite similar, okay, similar formula. Okay, the summary is, this is a general format. We calculate, we test hypothesis mean equals delta mean equals delta 0. Okay, we have 3 cases. For 1 sample from 1 population, 2 sample from 2 population, and also matched 2 sample from 2 population. Okay, then we calculate the difference. Okay, so this is the general formula. Next, we are going to show you how to calculate margin of error and how to calculate standard error, and for 3 different cases. And the case number 1, we learned from the previous chapter, and we treat it as a review.
Shutterstock Music. Shutterstock Music.
We are going to an in-class exercise. So if you are taking my course right now, you type .ice, in-class exercise. So let's look at, so this is chapter 10, we have 3, we have 4. So let's look for the 3, test of equal means. Okay, use up arrow key, then we enter 43. Okay, enter 43, and so I mentioned here, it's our hypothesis is mean 1 but mean 2 equals 0. Okay, I'm going to copy this one later. Okay, and we have 3 methods to get the data. The first one is we're going to use a check account. So this is check account. Okay, so dot a c check acc. Okay, then we get the data ID dot b 152. Okay, then we launch Excel, we paste there. Okay, so if you are not taking my course right now, then you can use download the CSV file. Alternatively, you can download a TXT file. Okay, so let's launch Excel and we paste it here. Okay, so our now hypothesis is mean 1 minus mean 2 equals 0. So I enter 0 here. So this is mean 1 minus mean 2 equals 0. Okay, so this is our now hypothesis. I make it bigger. Okay, I put the formula here. Okay, and also we assume alpha is 5%. So this is a 2-sided test. Okay, so this is 5%. Okay, and then we calculate mean. Okay, so this is 1, 2. Okay, and also we calculate standard deviation. Okay, we assume standard deviation is not given. And also, to simplify our calculation, it's likely to make a mistake. Suppose we calculate standard error, and we apply this formula. However, we just assume A. So this is variance divided by N1, variance 2 divided by N2. So it's square root of AB. Okay. And also, when we calculate degree of freedom, so equation 3b is, this should be, this should be 3c. Okay, so equation 3b is more complex. Then if we use simplified notation is A. So variance 1 divided by N1 is A. Variance 2 divided by N2 is B. So A plus B squared. And this is 1 minus N1 minus 1, A squared. And this is B squared. So we make our calculation a little bit easier. Okay. Okay, so let's calculate count. So this is count. We have to use so this is N, so this is 1, this is 2, so delete this 2. Okay, so this is count. So this is should be column A, data set. Okay, so we are going to use $A, $2. We're going to copy the formula. $31. Okay, then we can easily copy and paste formula here. Okay, I'm going to copy this formula down. Okay, formula down, and so this is we replace count with average. So we replace it average, and also we replace this with standard deviation. So this is standard deviation. Okay, then we can just copy this two formula here. Okay, okay. So this is our mean 1. So this is mean 2, standard deviation 1, and standard deviation 2. Okay, and we can calculate our difference. Okay, so difference is defined as mean 1 minus mean 2 equals mean 1 minus mean 2. Okay, mean 2. Okay, okay. So this is our hypothesis. Okay, so let's calculate standard error. So before we calculate standard error, so let's calculate B. Okay, so B will be standard deviation of 1, standard deviation 1, 2 divided by N1. So this is, so actually this is A. I'm going to, so this is A and this is B. Okay, so make it much easier. We can simply copy and paste here. Okay, so this is A, this is B. So let's check the B. Okay, so B will be F standard deviation of B2 divided by, variance of B2 divided by N2. Yeah, F6. So I'm going to use formula text equal formula text and show the formula of this. Okay. Okay, so let's look at the standard error. Okay, standard error. So standard error will be SQRT A plus B. Okay, it's less likely we make a mistake. You see here, according here, if we define this part as A, this part as B, it's simply the square root A plus B. Square root of A plus B. Okay, I'm going to make it bigger. So this is A, this is B, square root of A minus B. Okay, to calculate degree of freedom. Okay, so let's assume AA and BB and CC. Okay, so this is part is AA. So the numerator is AA, denominator is BB plus CC. just make our life a little bit easy. Okay, so AA equals A plus B squared. Okay, so this is AA. So this is numerator. Okay, the denominator is 1 over 1 minus 1 times A squared. Okay, sorry. Yeah, A squared. Okay, so this is 1. So this is 1 over N1 minus 1. Okay, so times A squared. Okay, A squared. So this is BB. Okay, so let's look at CC. CC is 1 over N2. N2 minus 1 times B squared. Okay, so this is B squared. I'm going to use show formula. Okay, I'm going to explain again. Okay, and for degree of freedom, and so this is original formula. Okay, and if we defined sigma 1 squared divided by n1 as A, sigma 2 squared divided by n2 as B, okay, then we can simplify. The numerator will be A plus B, you see, A plus B squared. Okay, denominator is 1 over n1 times A squared. Okay, the second part of the denominator is 1 minus n2 times B squared. Okay, finally our degree of freedom. Okay, degree of freedom will be AA divided by BB plus CC. Okay, so this is our degree of freedom. So let's treat roughly about 47. Okay, so this is okay. So let's calculate t value. Okay. Okay. I'm going to margin of error. Okay. The t value equals t inverse. Okay, I can use dot to t. Okay, or alternatively I use t alpha divided by 2. So probability will be alpha, and degree of freedom is 47. Okay, it's 47. Okay, so this is we got a negative value. Okay, and we calculate margin of error. Okay, margin of error is simply I use absolute t value times and standard of error. Okay, the standard of error will be this one. Okay, so this is, I'm going to show the formula. Okay, yeah, I'm going to show both formula of. Okay. Oh, sorry, there's no formula here. Okay. Okay, I'll repeat this one. We calculate t alpha divided by 2. Okay, why divided by 2? Because we have equal signs. Okay, our hypothesis is mean from sample 1 minus mean from sample 2 equals 0. Okay, and because we have two ways to reject it, it is two-sided test. Okay, so this is, oh, I forgot divided by 2. Okay, so this is E3 divided by 2. Okay, so this is our t value, and this is our margin of error. Okay, margin of error if absolute value of t times standard of error. Okay. Okay, so let's calculate lower bound and upper bound. Okay, so if we use the 0 around the 0, so 0 minus margin of error okay, equals 0 plus margin of error. So actually it's positive 77.8 and negative and positive. Okay. So let's do it again. If I'm going to use AND, okay, and so logical one is, so if our difference is greater than minimal, at the same time our mean is less than maximal, so this indicates we are inside, okay, then we accept null hypothesis, otherwise we reject. Okay, so this is obviously reject, okay, because 78 negative, 78 positive, so this is 106, it's beyond. Okay, so let's use formula text. Let's choose the formula of this. Okay, so this is, we have a logical AND. Okay, so AND, so this is first condition. Our difference is larger than minimum. At the same time, our difference is less than maximal. So inside the range, we accept. Outside range, we reject. Okay. Okay, so let's, this is T critical value. Okay, this is T critical value. So let's calculate our T value. Okay, T value. Okay, and again, the T value will be difference minus 0 divided by standard error. So this is difference. Okay, I know 0. Okay, difference minus 0. Okay, so this is 0. So divided by standard error. So this is our T value. Okay, our T value. I'm going to show the formula. Okay. So this is our T value. Okay. So our T value will be mean x1 minus mean x2 divided by standard error. Okay, so this is our decision rule. Okay, decision rule. Okay, the decision rule is if absolute of our T value, so it's less than absolute value of our T critical value, and we accept because this is inside the range, otherwise we reject. Okay, I'm going to show the formula. Show the formula. Okay, this is our second decision rule. Okay, the second decision rule is, so if our absolute T value is less than critical value, we accept, otherwise we reject. Okay, so this is rule number 1, rule number 2. So let's look at rule number 3. Okay, number 3 is P versus alpha. Okay, it's P versus alpha. So let's calculate our half P first, because this is two-sided, right? Okay, so this is T inverse. So let's use inverse. Okay, and so this is our, sorry, I use distribution, T dot DRST. Okay, dot DST. So this is our X value. So our X value is positive. Okay, it's positive. So actually we should use right tail. I'm going to explain later. Okay, so degree of freedom is 47 and 2. Okay, because this is right tail, so we should use 1 minus this one. Okay, so this is, I'm going to show the formula. Okay, show the formula. Okay, I repeat here the concept here. So if we calculate a negative T value, okay, we calculated negative t value. Okay, so difference, right? So actually it's difference minus our hypothesis. It's minus our hypothesis. Okay, so actually if the numerator is negative when we calculate t value, we compare with left tail. Okay, if the t value is positive, we compare with right tail. Okay, DST, right tail. Okay, so this is right tail. We don't have to use 1 minus left tail. Okay, so this is t. So this is t value, and degree freedom is 47. So we close it. Okay, then we get exact same result. Okay, I'm going to explain the concept here. Okay, and because the t, when the t is positive, then we have to use 1 minus t dist, because in this we want to use the right tail. Okay, alternatively we can use the t dot dist. Okay, so this is half p, then p will be half p times 2. Okay, so obviously it's simply times 2. Okay, so this is our decision. Okay, so if our p value is less than alpha, given alpha, we reject. Otherwise, we accept. Okay, otherwise we accept. Okay, so this is also reject. Okay, I'm going to copy the formula. Okay, just make it bigger. Okay, and so we have the 3 decision rule. Okay, the first decision rule is we calculate confidence interval. Okay, our confidence interval is negative 77.8 to positive 77.8. Because our difference is beyond, so we reject. The second decision rule I call the distance. Okay, then we calculate our t value and we compare with the t critical. So this is our t value 2.75, and our t critical value is negative, and we use absolute. Okay, absolute is 2.75, absolute t critical value is 2.0. Okay, because 2.75 is higher than 2.0, we reject. Okay, the last decision rule is we calculate the p value. Okay, if p value is less than alpha, we reject. If p value is higher than alpha, we accept. For the next exercise, we are going to try the same data set. However, we use Excel function. A few minutes ago, we conduct a hypothesis test, equal mean of 2 sample from 2 population, 2 sample draw from 2 population. We are going to do the same thing, and this time it's much easier because we use Excel function. So you type .ice in class exercise. Okay, we just do this one. It's 43, test of equal mean. So let's try 44. Okay, we just repeat 43. Now we use the Excel function. Okay, and so this is 44. Okay, and I'm going to copy this procedure to our Excel file. Okay, so let's Excel. So let's use a new one. So this is step. Okay, I'm going to show you we have some in A. Okay, so let's get the data. Okay, so get the data. So simply .b152. Okay, and launch Excel and paste. Okay, so let's paste our data set here. Okay, and so we have some NA. So this is missing code, and NA here, and also NA here. Okay, so let's try first why we have to remove this. Okay, so this is a string. So let's click data, and data analysis. And here we have t-test, 2 sample assume unequal variance. Okay, so for the next chapter, and for this kind of case, so usually we have 2 tests. The first test is we have to conduct a f-test to test whether they have equal variance or not. Then we go to back here. We choose if they have equal variance, we choose this test. If they have unequal variance, we choose this one. Okay, we postpone for the f-test to the next chapter. So let's assume they don't have equal variance. Okay, just click here, and so this is variable 1, so x1 range, x2 range, and so if we choose a label, so a1, b1 contains a label, we check this one. And because alpha is 5%, 0.05, so if it's 1%, we modify here, then we choose the appropriate data range. Okay, and so let's find some error message first. Okay, so I choose, so this is x1. Okay, so this is x2. So x1, x2, because I include a1 cell a1 cell b1, I check this one. Okay, and so I'm interested. I put the data output here. Okay, and I repeat. Okay, so we choose x1 column, so a column for x1, and b column for x2. Okay, and hypothesis range, I think we assume it's 0. Okay, we assume it's 0, and we include the label and 5%. Then output is D4. We click OK. Okay, so this is input range contains non-numerical data. Okay, so let's cancel it. Okay, I'm going to copy these two to another location. Okay, just make it, okay, I copy this one, so let's end a blank column here. Okay, and I'm going to move this one and do it to the bottom. Okay, so highlight this column. Okay, you click data, you click sort, and so this is this column. Okay, and from small to highest, just click OK. See, this is at the bottom. Okay, next time I only highlight to here, because this part I don't have to sort because this is at the bottom already. Okay, and so why I add a column, blank column? Because if I don't have blank column, and it will ask me whether only choose this column, not the complete data set. Okay. Okay, so let's do it again. So I click data analysis. I t-test, 2 sample assume unequal variance. Okay, so for the first one, I just ignore. Okay, I only include numerical value. The second one, I also only include numerical value. Okay, and 5%. Hypothesis mean difference is 0, and it's 5%. Okay, so let's choose location. So let's assume it is here. Okay, then I click OK. So this is our output. Okay, so this is our output, and so this method too is much easier. Okay, and I think the key is how to interpret your result. Okay, so this is mean of the x1, so mean x1, mean x2. Okay, and so this is variance, and if we use the square root, so this will be our standard deviation. Okay, so this is observation, so n1, n2, and this is degree of freedom. Okay, and so this is our t statistic, right? The t statistics, and we have two-tailed. Okay, so this is a decision. We call the distance, all right? compare absolute T versus absolute T critical. Okay. So this is our decision rule. Okay. So this is our decision. Okay. And so if our T value is higher than T critical, again, I'm use absolute value, then we reject. Otherwise, we accept. Obviously, we reject. Okay, so if absolute, like the absolute, accept, reject, or it's double quotation. Both should be double quotation and double quotation. Okay, I'm going to show the formula. So show the formula. Okay, I choose the T critical value 2 tail. So actually there are 2 T value, okay, critical value, and also we have another T critical, okay, because this is 2-tailed test, 2-sided test, okay, so we should choose this one, okay. So let's look at the P value. So this is decision rule number 3, okay, so this is P versus alpha, okay, P versus alpha, okay. Suppose our alpha is 5%. Suppose our alpha is 5%, so this is our, so if P value, so if our P value, is less than alpha, we reject. Otherwise, we accept. Obviously, we reject it. So let's copy the formula, okay, and make it bigger. Okay, so this second method, we test whether, so this is x1, we calculate mean, x2, we calculate mean. Mean is 1016909. So we have 2 means, okay. To test whether they have equal mean, and based on the T value, we reject. Again, we use T value. This T value and compare with T critical 2-tail. Okay. Alternatively, we can compare with P value with alpha. So if P value is then alpha, we reject. Otherwise, we accept.